Dear participants, welcome to our presentation. I am Damla Topallı. I am currently working as an assistant professor in the Department of Software Engineering, Ankara University. First of all, I would like to thank the organizers of HCI-E 2024 conference for providing us the chance to share our research with you. Today I will be presenting our work, which is titled as Investigating the Gender Effect on Skill-Based Task Performance, a case study on mobile and haptic-controlled user interfaces, which is co-authored by Eren and Professor Nergiz E.Çağıltay. Here is the outline of our presentation. Today, the endoscopic surgery is an alternative for the traditional surgical techniques where applicable. In this type of surgery, the surgeons need to use an endoscope and some specialized tools. In order to perform such kind of operations, the surgeons are required to gain several skills for using the endoscope in a proper way, such as the depth perception, 2D, 3D conversions, and eye-hand coordination. In order to gain those skills, simulation-based training environments are developed to support their skill acquisition. Skills learned in these simulations can be transferred effectively to the real-world operations, surgeries. These types of training helps to reduce the errors and also enhances the patient safety. Simulation-based training techniques can be also used for objective and cost-effective evaluation of surgical skills of the surgeons. But of course, there are some problems when using these computer-based virtual reality surgical training environments. One of these problems can be the gender differences. One of the factors we can say the gender differences. Understanding the individual differences can be critical to design better training programs individually for different groups such as female and male surgeons. Another problem in the field is the number of female surgeons, especially in the field of endoscopic surgery. Considering the performances of the surgeons in the virtual reality environments, some studies are reporting no differences considering the gender effect. But in the literature, there are some other studies which are reported some differences, significant differences between female medical students and male medical students. In one of the study, it is reported that the female medical students were less likely to be successful to complete the tasks in the given allocated time on simulators. As you can understand from these literature studies, there is no consensus on gender effect in this field. Accordingly, we hypothesize that it is critical to better train the surgical residents by understanding the gender effect. So the training programs can be developed by considering these individual differences. Hence, the aim of our study is to understand the performance differences among gender in 3D virtual environments by the use of classification algorithms. In this regard, our research question is, are there any performance differences among gender in 3D virtual environments? In order to answer this research question, we developed an experimental study. Two versions of an endoscopic surgery training scenario were used in this study. The first one is, you can see on the left-hand side, the haptic-controlled PC environment. Here, by the way, this scenario is developed as a result of a to-be-tucked project, which is coordinated by Professor Nergiz E.Çağıltay and the Neurosurgery Education Project. In this project, we develop a scenario to measure the basic skills of the participants. The task is to drill the bone. The participants is requested to drill the bone by using the haptic device. This tactical device is used to interact with the objects in the simulation environment like a real-world tool handling. So the participant use both their dominant and non-dominant hands in order to perform these given tasks. If the participant can drill the bone in the given time limit, the hole in here represented as a green. Otherwise, it is shown with a red color. In order to make a comparison between the environments, we adapted this scenario into the mobile environment. This scenario on the right-hand side is created during a project, undergraduate research project supported by Atılım University. Endoskopik cerrahi eğitiminde akıl destek sistemlerinin kullanımı, the title of the project. So we created a mobile version of the drill the bone scenario, which has 5 tasks. This environment is using a touch-based interaction. These joysticks are used for touch-based interaction in order to drill the bone. In the experimental study, 77 university students from the Department of Engineering attended, and mostly from the computer and software engineering departments. We have the 77 participants, 37 of female and 40 female participants. For the hand condition, we gather the data by using both their dominant and non-dominant hands in both haptic and mobile environments. When they performed the tasks, we recorded some measures, such as time to complete each task and the success value, which is representing if the participants successfully performed the task in the allocated time. You can see the distribution of our participants and the average age values. As we also mentioned previously, 37 female and 40 male students were voluntarily participated in this study. Distribution is given in the table on the slide. When we take a look at the results, our study is twofold. First of all, we try to understand the differences between two groups as male and female by using a statistical test, and then we use a classification algorithm in order to see if we can distinguish between these two groups. In the first part of our study, we use the independent samples t-test to understand the group differences in both environments. We consider these measures, scenario measures, like the time passed with the dominant hand and success with the dominant hand, time with the non-dominant hand, and success with the non-dominant hand in the haptic interface. When we use the haptic-based environment, we observe that there is no significant differences among the gender. On the other hand, when we compare these differences, again using the independent samples t-test in the mobile environment, we can say that there is a significant difference in both dominant and non-dominant hand conditions by using the time and success measures. The results show us that the male group performed the task in a shorter time with higher accuracy in the mobile setting. In the second part of our study, we use classification algorithms. These classification algorithms are Actually, 12 classification algorithms are used in this study, including the statistical methods like naive Bayes or regression, support vector machines, some lazy learners like the k-nearest neighbor algorithm, ensemble models, boosting algorithms, rule-based models, and the decision trees. We use these algorithms by using a tool, a data mining tool called VECA. We run these algorithms with different parameters in order to obtain the highest accuracy. For the training and evaluation of the classifiers, we use tenfold cross-validation method. When we run the classification algorithms, first we use the all features that are extracted from the simulation environment. All feature set includes 10 attributes. These attributes are listed in this slide. First, the PC game attribute. This feature is representing the frequency of their frequency of playing the computer games. In the beginning of the study, we applied a questionnaire and asked them some questions about their demographic information and frequency of playing the computer games. 0 represents none or rare, 1 represents they play the computer games frequently. Also, the time passed to complete the tasks. We take the average of first 5 tasks on the haptic environment with dominant and non-dominant hand. Success of the tasks also along with the time measure. And in the mobile environment, similarly, we gather time passed to complete the task and the success of each task. Also, we have a class attribute. Of course, it is the gender, male and female. We use these labels for the classification. When we apply the classification algorithms with all features, we have obtained the accuracy of 79% by using the logistic regression and KNN algorithm when K is chosen as 9. Of course, maybe this accuracy value is not high enough, so we need to perform a feature selection step. We use a ranked-based algorithm, relief algorithm in VECA to select the features. As a result, we use these 7 selected features. It is increasing the accuracy to 80.5% with the logistic algorithm. We only use these features like the frequency of playing the computer games, time and success with only the non-dominant hand option in haptic base, and both with dominant and non-dominant options in the mobile environment. When we come to the conclusion, we can see that in order to understand the gender effect, first we apply an independent sample t-test to represent the group differences. No significant differences can be found in the gender effect in the haptic-based environment, but there is a significant difference between female and male in mobile environment on the contrast, which is having a more familiar interface compared to the haptic-based setting. According to these results, male performed the tasks in a shorter time with higher accuracy in the mobile environment. This finding is also in line with the previous findings in the literature. Additionally, we search for the classification algorithms if it is possible to use the classification algorithms to categorize the performance of surgeons among gender. Then we obtain the result of 80.5% accuracy by using the logistic regression algorithm. Of course, these results can be further improved or enhanced by using some additional scenarios and by increasing the number of samples, which we can report as the limitation of these studies. The number of studies regarding the gender can be the one of the limitation in the literature, as we found. This work is conducted with the engineering students, which is a preliminary work, but affecting the field of surgery. Some experimental studies can be designed with the surgical residents. And also another limitation can be reported as the task complexity. The tests in the study are only used for gaining the basic surgical skills. But of course, there can be more realistic scenarios developed for real life experiences in order to better understand their performances in real life experiences. In this regard, the future work can be explained like this. We can perform some experimental studies by including a broader range of the participants, such as more experienced surgeons and novice surgeons. Additional measures can be used. We use only the time and success measures during this process, but also there are some additional measures can be collected, like the tool distance, deviation, and the error count. Also, nowadays with the advancement of the VR, AR, and MR technologies, we can use different platforms for further performance comparisons, such as using the virtual reality and augmented reality to assess the best training tools. Here are the references of our study. Thank you very much for listening to this presentation. All of your questions and comments are welcomed. Thank you.